Welcome to the Professor's DuBois channel. This is Professor Corey, and in this video, I'm just going to kind of talk through a section of MindTap that you'll have to do, and that's 4.5D titrations. So I'm on that screen now, and what we have is it's a simulation of a titration, and this is a technique that you'll be doing in lab. But it's a little confusing, I think, the first time you see it, so I think this might be worth going through. So they start out saying that we're going to titrate an unknown acid, and it says down below that it's a diprotic acid. So what that means is we have two hydrogens that are donatable on this acid. So it could be something like H2SO4. That would be an example of a diprotic. But this one's unknown. We don't know exactly what it is. But we have it in this Erlenmeyer flask. That's what they're showing here, is an Erlenmeyer flask. And we have a known volume at 25 mils. Up here we have a burette. So this is, you're familiar with lab, the burette, and there's the valve down at the bottom. So the burette contains sodium hydroxide. And what we're going to do is we're going to open that valve and add sodium hydroxide to the acid, and we can control and measure the amount that we've added. And what we're doing is we're creating a chemical reaction. So whenever I'm going to study a reaction, I want to know what the reaction looks like. So I can write this out. The tricky part is I don't know what the acid is, but I can write this out with my diprotic acid is just H2A. So the A is just acid. I've got two protons and an A for acid. So the A is not an element, but since it's an unknown, I'm just gonna call it H2A. So I'm going to add sodium hydroxide, producing a sodium salt of whatever that anion is, and water. And when I balance it, I realize that I use 2 NaOHs for every one of this unknown acid. So that's the mole-mole relationship there. So let's go back to this. When I add sodium hydroxide, I want to stop at the point where all of the acid has been consumed. I think I'll go back to this. So I'm adding sodium hydroxide. There's an amount of this. I've got 25 mils. I don't know what the molarity is. That's what I want to figure out. But I'm just going to add sodium hydroxide until that's consumed. And so that's gone. And I'm adding sodium hydroxide, so I stop as soon as that's consumed. So there's none of this left in there. So all that exists in that flask are my products. I've got the sodium salt and the water. There's no reactant. And this is different than a limiting reactant type problem where one of the reactants is in excess. So when we're doing a titration, there's no reactants. And we call that the equivalence point. And that's the point when there's equivalent amounts of acid and base. We could think of it like that. So the equivalence point is what we're trying to achieve. And the way we achieve it, wrong slide, the way we achieve it is we add an indicator. And there's a bunch of indicators here. And what indicators are they're compounds that have different colors and different pH ranges. So I'll just kind of play with these a little bit. I've got acid in here, so my phenolphthalein is colorless in the acid, while methyl orange actually has a color in acid. It looks like kind of a pink color to me, and thymolphthalein, colorless. So they actually asked us to select phenolphthalein in this question, so I'm going to do that. And then it says to titrate 1 ml at a time until the solution turns pink and make note of the volume added. Okay, so this is how I add the base. That's what they mean by titrate. When I open this valve on my burette and add that solution, I'm titrating. Here we can change the concentration of the sodium hydroxide, but this question didn't say anything about that, so I'm gonna leave it where it is. And I'm going to add this just 1 ml at a time, and you can see that volume increase. And I'm looking for where it turns pink. And I can do this fairly quickly because this is just my first shot. And there we go, 46.00 mils. The solution turns pink. And so I know that this indicator turns pink. I didn't mention that. The indicator goes from colorless in acid to a pink color in a basic pH. I've turned pink, so I've most likely added excess of NaOH. And what I really want to achieve is this equivalence point where I have nothing but products. So I'll have the salt and water. So I make note of that because I'm going to redo this titration or retitrate, and I can get closer to the actual number by adding the base in smaller increments. So let me just select this retitrate, and it just resets everything. I've got 0 base added. I'm back to the 25 mils of the acid. So this time I'm going to go up to 45. And I can go up to 45 quickly, but then I got to really slow down because I don't want to do this a third time. And I'll start slowing down now, right? So there's my 45.00 mils, and you can see my solution hasn't started to turn pink. So I'm going to add just the tiniest little amount, 0.05 mils. And when I do that, this color is a very faint pink. And I'm going to say that that's my equivalence point. So I have 45.05 mils. That's the amount of the sodium hydroxide. And I know the molarity, 0.50. So I can go from milliliters to liters and then use the molarity to get moles of sodium hydroxide. And I know that the mole-mole relationship between the sodium hydroxide and this unknown acid from my chemical equation. So that's good. I can get the moles of this acid. Now the question's asking for the molarity of the acid. So that's the concentration of this acid. And the molarity is the number of moles, which I can calculate, divided by the number of liters. And in this case, we have 25 mils of acid. That's a known amount. So I can convert this to liters and get the molarity of this acid. So I wanted to set this up for you so you could take a look. So here is my volume of the sodium hydroxide I added with the burette. I have it in mils, so I'm going to convert to liters. The molarity of this sodium hydroxide was given, 0.50 moles per liter. My liters cancel here. I'm left with moles of sodium hydroxide. And this is from the balanced equation. So this is reaction stoichiometry. You can see there's 1 of the acid to every 2 sodium hydroxides. I've got my moles sodium hydroxide set up to cancel. And there's my moles of acid. So that was the number of moles of the acid in 25 mils. I just converted it to liters here. So dividing moles by liters, I get 0.45 big M for molarity of the acid. So I could also write that as moles per liter. 2 sig figs came from the molarity of the NaOH. I figured that had to be standardized. And also, they just said 25 mils of the acid in that Erlenmeyer. So 2 sig figs for that answer. Should be good to go. Hope you found this useful. I hope it's helpful. Good luck. Practice this. You'll get to do it in lab. It's a really cool technique. Works very well. So thanks for watching. Give the video a thumbs up if you like it. Subscribe. Watch more videos. Study a lot. Have fun. Good night.